Morning, everybody. My topic is Atabecestat in preclinical Alzheimer disease. My university. Introduction. My name is Boris Josue Mendoza Menendez, and here we have my social media. Definition. Alzheimer disease. Alzheimer's disease is a progressive disorder that causes brain cells to wither away, degenerate, and die. Alzheimer's disease is the most common cause of dementia and continuous decline in thinking, behavioral, and social skills that disrupt a person's ability to function independently. With respect to symptoms, we have early symptoms. In the early stage, the main symptoms of the Alzheimer's disease is memory lapses. For example, someone with early Alzheimer's disease may forget about recent conversation or event, misplace items, forget the name of place and object, have trouble thinking of the right word, ask questions repeatedly. We respect middle stage symptoms as Alzheimer's disease develop memory problems which get worse. Someone with the condition may find it increasingly difficult to remember the names of people they know and may struggle to recognize their family and friends. Other symptoms may also develop, such as increased confusion and disorientation, obsessive delusions, or feelings paranoid or suspicious about careers or family members, aphasia, depression, hallucination, vascular dementia, and later symptoms. In the later state or of Alzheimer's disease, the symptoms became increasingly severe and can be distressing for the person with the condition, as well as their careers, friends, and family.
Many people, as they get older, may notice changes in memory and thinking abilities. At first, these changes may be so subtle that they're easy to explain away as normal aging. And they may be. However, it's also possible that they're the earliest symptoms of Alzheimer's disease. Alzheimer's disease, or AD, is the most common form of dementia and accounts for 60% to 80% of all cases of dementia. In the United States alone, it is thought that one person develops AD every 66 seconds on average. In the early stages, people with AD may notice everyday tasks becoming more difficult to perform than before. Some typical early symptoms of AD you may notice include facing increased problems with memory, struggling to find the right words for things, becoming confused about time or place, having trouble managing money or paying bills, experiencing changes in mood, personality, or judgment, misplacing or being unable to find things. The symptoms of AD arise because of slow, ongoing injury to different parts of the brain. This injury, which affects nerve cells, is believed to be the result of two different processes that occur in the brains of people with AD. One involves a protein called amyloid beta, or A-beta, and the other involves a protein named tau. In the first of these processes, A-beta starts to collect inside the brain. This may begin as many as 20 years before the first signs of AD appear. A-beta is produced inside the brains of all people, but in healthy people, it is removed by the body before it can cause harm. In the brains of people with AD, A-beta clumps together in bigger and bigger groups and forms clusters known as plaques. As time goes on, plaques begin to form in more and more parts of the brain, which are responsible for learning, memory, and other tasks. The second process, involving tau protein, begins about 15 years before the first signs of AD appear. Tau normally plays a helpful role in the brain. However, in people with AD, tau becomes altered and forms tangles within nerve cells. Eventually, the processes involving A-beta and tau can injure nerve cells. As this injury affects one brain region after another, it leads to the appearance of symptoms you may recognize. AD is a disease that progresses over time, leading to worsening symptoms and can ultimately cause death. However, studies suggest that early diagnosis and intervention could potentially slow the course of AD and may help protect the brain from further injury. Furthermore, an early diagnosis allows you to consider participating in a clinical study investigating new potential treatments. Today, there are tools available that might help doctors diagnose AD in its early stages, including various lab tests, written tests, and interviews. To confirm whether you have AD, your doctor may order an imaging study known as PET-CT, which can spot A-beta plaques inside the brain. Your doctor may also request a procedure to test a sample of your spinal fluid for abnormal levels of A-beta and tau. Spinal fluid is a clear, colorless body fluid found in the brain and spine. Currently, the only approved therapies for AD help address some of its more advanced symptoms. However, there are ongoing efforts to develop treatments that, if approved, may delay, stop, or prevent the progression of AD. In addition, studies suggest that a lifestyle that includes a healthy diet, regular exercise, social interaction, and cognitive stimulation may be helpful. For decades, a large and growing community of healthcare providers, research scientists, universities, patient advocacy organizations, and pharmaceutical companies has been committed to battling this disease, and their efforts yield promising new discoveries with each passing year. Over 500 clinical studies with many thousands of participants across the globe are helping to advance our understanding and potential treatment of AD. In the fight against AD, you are not alone.
Beta secretase enzyme, or BASE. The beta amyloid peptide is the major constituent of amyloid plaque in Alzheimer's disease brain and is likely to play a central role in the pathogenesis of the devastating neurodegenerative disorder. The beta secretase side amyloid precursor protein cleaving enzyme is the enzyme responsible for initiating beta amyloid regeneration. Thus, BASE is a prime drug target for the therapeutic inhibition of A production in Alzheimer's disease.
Following synthesis in the endoplasmic reticulum, APP is transported to the trans-Golgi network. The newly synthesized ATP protein is transported from the PGN to the plasma membrane via the endocytic pathway. APP undergoes clathrin-mediated endocytosis and is recycled back to the trans-Golgi network through the endocytic pathway. The retrograde transport of APP from the early endosome to the recycling endosome occurs through the interaction of APP with the retromer complex. Under disease conditions, APP at the plasma membrane is sequentially processed by beta and gamma secretases to generate amyloid beta fragments. This is referred to as the amyloidogenic processing of APP. Amyloid beta fragments have a propensity to aggregate and form oligomers, which eventually form large pertinaceous deposits known as amyloid plaques. APP, along with beta and gamma secretases, can be transported to late endosomes for processing. A subset of amyloid beta peptides are recycled back to the surface and released into the extracellular space. Another subset of these amyloid beta peptides is transported to the lysosomes for degradation. Amyloid beta and amyloid plaques bind to several receptors on microglia, which help clear pathogenic aggregates. Individuals with Alzheimer's disease express variants of the microglial receptor TREM2 that have reduced ability to bind to amyloid beta complexes. Amyloid beta can also drive persistent neural inflammation by binding CD36 on microglia and rupturing lysosomes following internalization, which causes the production of inflammatory cytokines such as IL-1 beta. Amyloid beta oligomers interact with different surface receptors and can re-enter the cell via several mechanisms. Amyloid beta oligomers can mediate the formation of P75-NTR sortilin death receptors and also create pores in the plasma membrane. This results in ER stress or mitochondrial-mediated activation of caspases, which triggers the cleavage and aggregation of tau. Amyloid beta can also bind to low-density lipoprotein receptor-related protein 1, leading to endocytosis through the clathrin-dependent pathway. It can then traffic to the lysosomes for degradation. Here, we reviewed how amyloid beta is generated from APP on the cell surface, and how these proteins are taken up, recycled, and/or degraded in the cell. We also covered how amyloid beta triggers caspase-mediated cell death and neural inflammation. For more information, visit biolegend.com.
Application in medicine. BACE, the beta secretase in Alzheimer's disease. The study of disease genes that cause Alzheimer's disease has revealed important clues about the pathogenesis of this disorder. Family Alzheimer's disease cases are caused by autosomal dominant mutation in the gene for amyloid precursor protein and the presenilins. In education patients with amyloid precursor protein gene duplication or individuals with Down syndromes who have increased dosage of the amyloid precursor protein gene develop early once Alzheimer's disease. Beta secretase enzyme or BACE inhibition has been proposed a priority treatment mechanism for Alzheimer's disease, but treatment initiation may need to be very early. We present proof of mechanic of Atabecestat, also known as GNJ 54A61911, and oral-based inhibition for the treatment of Alzheimer's disease. In model simulation confirmed that once Doyle 10 mg and 50 mg Atabecestat can attain 60 and 70% and also 90% beta amyloid. Since the discovery of BACE1 a decade ago, our knowledge about this enzyme has increased significantly. Based on the crystal structure of BACE1 and medical chemistry study, significant progress has been made toward the development of a small molecular inhibition capable of penetrating the blood-brain barrier and having sufficient potency to inhibit beta amyloid generation in vivo. However, despite promising new of phase 1 inhibitor development, phase 1 therapeutic for routine Alzheimer's disease treatment aren't yet available. Also, phase 1 small molecular inhibitor, mechanical chemistry, and pharmacokinetics have proven chaining the resonant entry of at least one phase 1 inhibitor into clinical trial is an encouraging advance toward phase 1 therapeutic innovation for the treatment of Alzheimer's disease. That was issue applied in Ecuador. Video.
Absolutely. When you think about drugs that are still in development against amyloid, there are numerous agents. There are two general classes of these. One, we can block the deposition of amyloid or the abnormal processing on the front-end side, or we can try to remove amyloid once it's been deposited abnormally in the brain. So on the input side, we're approaching the base enzyme. This is one of the enzymes that cleaves the amyloid precursor protein in an abnormal spot. So we can block that enzyme with base inhibitors. So if they are effective, that stops the accumulation of the abnormal protein. The other tack is to use, say, an antibody to remove the amyloid once it's been deposited in the brain, or remove it in its formation phase, the soluble to insoluble forms, the aggregate forms early in the process. So we can take those two avenues of approach, and there are still active programs on both ends.
So most recently, the approaches that are anti-amyloid approaches have fallen into two bands for the most part. There's the base inhibitors that are really trying to turn down the spigot of toxic amyloid production. And then there's the sync approach with the antibodies that trying to take out the plaques and also even monomers or oligomers and protofibrils. And unfortunately, as I mentioned, a number of programs, including aducanumab and canakinumab this year, have either read out or been reported to be negative or futile. We're still waiting to see actually if there are signals, for example, in individuals where there was plaque removal to a certain level, and whether there was any congruent changes in cognition or clinical benefit, and that data has to still come through. As far as the base inhibitors, which is the spigot approach, of the 7 programs, 5 of them have either read out as futile, or there have been small signals of a small, actually detrimental time to function. But 2 of the programs are still ongoing. They have not read as negative, and so we're waiting eagerly to see whether those programs could show a signal, either at the later stage, or some of these drugs are also in development and for earlier stages in secondary prevention of Alzheimer's disease. People with risk or who already show disease pathway but really don't have a tremendous amount of symptoms. That is still outstanding. Whether early enough some of these interventions can modify the trajectory. Certainly with the current readouts, it becomes a bit more pessimistic. But I don't think that answer has been found yet.
Pros and cons. Pros. In model simulation, confirmed that once Doyle, thanks mg and 50 mg, Atabecestat can attain 60 or 70% and also 90% beta amyloid. Cons. However, despite promising new of phase 1 inhibitor development, phase 1 therapeutic for routine Alzheimer's disease treatment aren't yet available.
One in 10 Americans over age 65 is living with Alzheimer's disease.
It's the most costly disease to our society right now. It exceeds cancer, it exceeds heart disease with regard to costs to society.
There is no cure for Alzheimer's disease, only medications to help treat the symptoms. And now, news about a drug that may slow the progression of the disease. Dr. Ronald Peterson says he's cautiously optimistic about BAN 2401, an antibody that showed reduction of amyloid accumulated in the brain during clinical drug trials.
It was suggestive that this drug may in fact remove one of the toxic proteins from the brain that causes Alzheimer's disease.
Dr. Peterson says while it was a very complicated trial design, the research is encouraging.
It gives us a shot in the arm because there have been so many failures of major drug trials in the Alzheimer's field in the last 10 years, that when we see a positive signal like this moving in the right direction, clinically and biologically, it's encouraging.
For now, he recommends exercise for the body and mind along with a heart-healthy diet.
There is a fair amount of evidence that exercise, aerobic exercise, maybe some resistance training as well, can actually slow the progression or delay the onset of clinical symptoms.
Keep intellectually active, stay socially involved, and enjoy a Mediterranean diet, all ways Dr. Peterson says to support brain health and possibly reduce the risk of Alzheimer's. For the Mayo Clinic News Network, I'm Ian Roth.
Conclusion. Beta secretase enzyme or BACE inhibition has been proposed as a priority treatment mechanic for Alzheimer's disease, but treatment initiation may need to be very early. We present proof or mechanic of Atabecestat, also known as JNJ5486191, an oral-based inhibitor for the treatment for Alzheimer's disease. In model simulation confirmed that once dosed, thanks mg and 50 mg, Atabecestat can attain 60 and 70% and also 90% beta amyloid. JNJ 5486191 at 10 and 50 mg jail close after 4 weeks result in reduction of 67% and up to 19% in both.
Alzheimer's disease, AD, is the most common form of dementia among older people. Dementia is a brain disorder that seriously affects a person's ability to carry out daily activities. AD begins slowly. It first involves the parts of the brain that control thought, memory and language. People with AD may have trouble remembering things that happened recently or names of people they know. A related problem, mild cognitive impairment, MCI, causes more memory problems than normal for people of the same age. Many, but not all, people with MCI will develop AD.
In AD, over time, symptoms get worse. People may not recognize family members or have trouble speaking, reading or writing. They may forget how to brush their teeth or comb their hair. Later on, they may become anxious or aggressive, or wander away from home. Eventually, they need total care. This can cause great stress for family members who must care for them. AD usually begins after age 60. The risk goes up as you get older. Your risk is also higher if a family member has had the disease. No treatment can stop the disease. However, some drugs may help keep symptoms from getting worse for a limited time.
Thank you so much for your attention.